Welcome back to the Scotti-BYTE channel, and this is Scott. So usually on the channel I discuss LXD containers, but this time I want to go ahead and discuss Incus. And if you're familiar with my channel, you know that I have a tutorial entitled LXD Step by Step, and so I wanted to complement that video by creating an Incus Step by Step. So if you're not aware, Incus is an open source next generation container and virtual machine manager. Incus is supported and maintained on linuxcontainers.org. And Incus is similar to LXD, except that LXD is maintained and supported by Canonical. Incus containers are used for operating system virtualization, and those containers are created from images, which is far faster and more efficient than virtual machines, which also virtualize the hardware, and they require an operating system installation. So in this tutorial, I will do a step-by-step installation and configuration of Incus from scratch. The first thing that we want to do is navigate over to ubuntu.com/download, and over here you'll see that there's an option to download an Ubuntu desktop. We want to instead go click on the server option, and we want to download the server variant of Ubuntu, and just go ahead and click download Ubuntu server 2204 LTS. So for you Windows users, the main difference between having an Ubuntu server and an Ubuntu desktop is the server does not have a GUI, and so it runs a little bit more efficiently. And really, for our Incus server, there's no real reason that we need to have a GUI interface on that system, and so it'll run a little bit more efficiently without that interface. Ubuntu server is very reliable and also very resource efficient, and I recommend installing it on a dedicated machine. But if you don't have an available dedicated machine, then you can also install it on a virtual machine. However, my suggestion is in either case, you want to dedicate 4 cores minimum and also 16 gigs of memory. And the reason I suggest 16 gigs of memory is because that way you can create at least 10 containers, and having less memory really limits the amount of containers that you can create. If you're installing your Ubuntu server on a dedicated machine, then you can go ahead and go over to the Baliner Etcher site, which is etcher.balena.io, and when you go over to this site, you can download a copy of this program and go ahead and write the Ubuntu server ISO over to it, and then you'll be able to boot that USB device on your dedicated machine and proceed with the installation of Ubuntu server. And for my purposes, what I'm going to do is I'm going to use the ISO file directly, and I'm going to create a virtual machine in my demonstration. But in either case, the steps from this point on are going to be the same. Once you boot your Ubuntu 2204 server, you'll get this menu, which gives you the option to try or install Ubuntu server, and then you have a couple of other options. We're going to choose the option to try or install Ubuntu server. So I go ahead and hit enter here. I'm choosing English as my install language, and I'm continuing, but I'm going to update to the new installer. So I arrowed up to update to the new installer. I'm leaving my layout and variant as English, and I have done highlighted at the bottom of the screen. I'm hitting enter. And then the best installation is going to be Ubuntu server, not Ubuntu server minimized, but Ubuntu server. and I go ahead and select done. The next thing we have here is the option to enable either DHCP or a static address. I'm going to go ahead and use DHCP because I always promote the use of DHCP address reservations from your router. So then I'm going to click done here, and I'm going to click done at the proxy address. And then it asks for an alternate mirror, and I'm not going to choose an alternate mirror, so I go ahead and hit done here as well. And then you have the option to use the entire disk and set this disk up as an LVM group. That's fine. I go ahead and tab down to the done option. In my case, I have a 100 gigabyte disk, and you'll notice here if we scroll to the option that says Ubuntu new to be formatted on the root device, and it's going to format it as 48 gigabytes. I'm going to highlight that, and I'm going to hit enter. And then I'm going to hit edit. And then over here, I'm going to go ahead and set it to the max size. And the max size is indicated to the left at 97.996 gigabytes in this particular case. Depending on the size of your disk, that may differ, but generally it makes the root size a little bit smaller. I want the root size to be equivalent to the entire disk. I arrow down to the save option and I hit enter. And now you can see that it is actually using the entire disk, and I move down to the done option and I hit enter. And so it says selecting continue will begin the installation process, and it will delete everything on the disk. So I go ahead and arrow down to continue and I hit enter. Now it asks for my name, and I'll go ahead and type in Scott once I get in that field. Then it asks for the server name. In this case, I'm just going to name my Incus server Incus. And then I'm going to pick a username, which will be Scott, and I'm going to pick a password. You want to remember this password, so make sure and put it in a password manager or write it down someplace. And then we hit done. And then it comes up and says upgrade this to Ubuntu Pro. You can opt to do that if you want. I like Ubuntu Pro, but I'm going to skip that step for now. Go ahead and continue. And then you do want to put a check mark and install OpenSSH Server, because SSH Server is going to be how we communicate with this server in order to install Incus. And then I tab down to the done option and I hit enter. At this point, you have an option to install a lot of other software. I'm going to tab down to done. And it really is a best practice not to install additional software on your server that will be running Incus to keep it as efficient as possible. So I go down to the done option and I hit enter, and the installation will continue from here. Once it indicates that the installation is complete at the top of the screen, you can go ahead and arrow down to the option that says reboot now and hit enter, and the system will reboot. At this point, you should remove your installation media, assuming it was a USB drive that you had created with Ballenger Etcher, and then you hit enter once you've done that, and the system should reboot normally. At this point, you can hit enter, type in your username, and then type in your password, and you should be logged in. So you can do an IP space A, and it will give you the address of your system. In my case, it's 172.16.1.91, and I want to take a note of that address. Now I can go ahead and exit out of the server by typing exit, and then we're going to log in to that address from an SSH terminal. Here I am on my desktop, and I'm going to do an SSH over to 172.16.1.91, which is the address of our new server. And in this case, I got a message telling me that that address has been used on my network previously before. So I'm going to go ahead and use SSH keygen to remove it as it indicates. And then I'm going to go ahead and try to connect to it again. And I say, yes, I'm sure I want to continue connecting. And I go ahead and type in my password. And it logs me into the new machine. Notice that it says that 51 updates can be applied immediately. I'm going to go ahead and do a sudo apt update. Type in my sudo password, my login password, and it will go ahead and tell me again that I have those updates available. And I'm going to do a sudo apt upgrade -y so it doesn't prompt me, and it will go ahead and apply all of those new updates. You should always apply all of the new updates after installing a new system. Now that all my updates are installed, I'm going to go ahead and clear the screen with a Control-L, and then I'm going to do a sudo apt install net-tools, which is convenient to look at my networking configuration. A little bit more convenient than it is to use the IPA command because it's easier to read. So I'm going to do an ifconfig command, and here you can see that my physical Ethernet device is ENP1S0, and then I have a loopback device. So really a very simple network configuration. And here we can see that we have the 172.16.1.91 address. Once we install Incus, we're going to be creating multiple containers, and those multiple containers can be viewed as multiple servers. Well, the problem with ENP1S0 or any physical Ethernet device is it cannot be shared amongst multiple systems, and we want to produce our containers and have them show up on the main LAN. So in order to do that, we want to add a switch. So if you're familiar with a hardware switch, you know that it is a way to connect more than one system to your network. And a virtual switch can do the same thing. In order to do that, we need to install the virtual switch component, which we do with a sudo apt install open vswitch-switch. I provide my sudo password, and it goes ahead and installs the virtual switch component. To change our network configuration, we want to do a cd over to /etc/netplan and do a ls to list the files over there. By default, a new installed system will have usually a single YAML file. You may have more than one. You can feel confident in deleting all of them, and they'll generally start with a number like 00, and in this case I'll go ahead and edit. I'll do a sudo nano on 00-installer-config.yaml. And so this file is a very basic configuration file. I just made note of the fact that it uses ENP1S0, which is our physical device that we noted from the ifconfig command earlier. So I'm doing a Control-K to delete all the lines in this file, and then I'm going to go ahead and paste in a new network configuration file. So I'm using my ENP1S0 device, as you can see on this line, and again I'm using it on this line here, and then I have my address set to 172.16.1.91 only because that was the same address that we're now SSH'd into. Even though I'm setting this as a static address, I'm still going to reuse the same thing and then go ahead and set a DHCP address reservation on our router later. This defaults or routes to default via is going to be your default gateway. In my case, it's 172.16.0.1. In your case, it might be 192.168.1.1. Your address is probably going to be 192.168.1. some number /24, indicating that you have a subnet mask of 255.255.255.0. Mine differs. And then down here, I have two name server addresses, and those are the name server addresses for Cloudflare. I do a Control-O and an Enter to write the file out, and a Control-X to exit the nano editor. Just as a reminder, if we do an ifconfig command again, we have enp1s0. Now, if I do a sudo netplan apply, it will apply the new network configuration, and I should get a prompt back shortly. Now that the netplan command has completed, I can do another ifconfig command, and now you'll notice that enp1s0 is no longer getting an IP address, but the device, the new device, which is our virtual bridge called bridge 0, is getting the same address of 172.16.1.91, and that's what kept me from disconnecting from my SSH session. And now that we have our bridge, we can go ahead and move along and configure or install and configure Incus. Let's go ahead and CD back to our home folder. And at this point, I'm going to do a curl command, and that will list the Incus keys. And there they are. And these are the Incus Zably builds, which is where the builds are being maintained at on GitHub. And then the next thing we want to do is we want to go ahead and create ourselves a folder to store our keys, and we're going to do that with the sudo make-dir path on /etc/apt/keyrings. And then we're going to go ahead and do a curl command over there, and we're going to sudo this curl command as well, and it will go ahead and place those keys over there. And since I'm going to be doing more commands that require sudo, I'm going to go ahead and do a sudo su just so that I'm root. Now that I have the keys installed, I'm going to go ahead and add the repository with this command, which I will include obviously in the show notes. It has now added that. Now I can do a sudo apt update, and it will go ahead and process in those updates. At this point, we're ready to install Incus. I'm going to go ahead and exit and go back to my regular user account. So let's install Incus now with the sudo apt install on Incus. And I go ahead and say yes, and it installs our Incus server. I'm going to add my account to the Incus admin group so that I don't have to issue the sudo command every time I issue Incus commands. And I'm going to do that with the sudo usermod -a capital G Incus-admin to my user account Scott. And then after that, I'm going to do a new grp of Incus-admin, and that goes ahead and makes that live, and I can type the groups command, and you can see that in fact I am in the Incus-admin group. Before I initialize Incus, I'm going to go ahead and install the ZFS utilities so that I can create a ZFS pool for my containers. And I do that with the sudo apt install ZFS utils-linux, and I go ahead and type Y to continue, and it goes ahead and installs the ZFS utilities. Before we can begin using our Incus server, we have to initialize it for first use, and that command is going to be incus admin init. The first question we have is, would you like to use clustering? We say no. Do you want to configure a new storage pool? Yes, we do. Name of the new storage pool, and by default it is default, and that's a good option to keep. And the next thing is name of the backend storage pool to use, and I'm going to choose ZFS, which is the default. If you do not see ZFS in this list and it defaults to BTRFS, simply reboot your server, and the next time around when you do the incus admin init, you should see ZFS as an option. Then it says, do you want to create a new ZFS pool? Yes, I do. And would you like to use an empty block storage device? Since I don't have an empty disk, my answer is going to be no, and it's going ahead and creating a virtual disk instead, which is a ZFS disk inside of a file. For my purposes, I'm going to go ahead and configure that at 50 gigabytes because that's all I believe I'll need for purposes of this demonstration. You're going to want to size this much larger in your case. So I go ahead and hit enter, and then it says, would you like to create a new local area network bridge? The answer is yes. And what should the bridge be called? And Incus BR0 is just fine. This is for the internal NATed bridge and not our bridge 0 that we created earlier. What IPv4 address should be used, and we can go ahead and set that as auto. Same with IPv6. And would you like the server to be available over the network? And so we can do remote management of it. We want to say yes. And then the address to bind to, default is all for all network interfaces. Since we only have one, all is appropriate. I hit enter, and the port number to bind to by default is 8443, just like it was with LXD. And since the only server I'm running on here is Incus and not Incus and LXD, 8443 is free and available. So I hit enter. Would you like to stale cached images to be refreshed? And the answer is yes. And then would you like your YAML printed out that does all of this? And I don't really want to see it because I know what I've answered so far. And I go ahead and hit enter, and it goes ahead and completes the init process. At this point, Incus is fully installed, and you can certainly do an Incus list command to see the containers that you have available. But we haven't created any containers yet, and so you aren't seeing any. If you want to list all of the images from which you can create containers, you can do the command incus image list images : and you'll get a long list of various containers. Let's go ahead and create our first Incus container, and I'm going to do that with incus launch images : Ubuntu /22.04, and I'm calling the name of the container first. It's retrieving the image from the image repository, and it's starting the container from that image. And now the container is started, so we can do a LXC, or not LXC, but Incus list. And the Incus list command shows that the container name first is running, and it's running at address 10.253.219.108. So this address is a NATed address that is internal to the NAT network that Incus creates by default. But we want to go ahead and offer an Incus container out onto our main LAN. In order to do that, we need to be able to create a profile. And as I have with my LXD in the past, I'm going to go ahead and do an Incus profile create bridge profile. And that creates a profile called bridge profile. And we have to make some settings on that bridge profile. And the settings we're going to make are to add the device ETH0, which is the device inside the container, and we're going to say that it is a NIC with the NIC type bridged, and it's going to bridge back through the parent bridge 0, which, as you'll remember, was our virtual switch that we created with NetPlan. So then it says device added to bridge profile, and at this point our bridge profile can be used to create containers. Now we're going to launch a second container with the command Incus launch images :Ubuntu /2204 again, but we're going to call the name of this container second, and we're going to give it the default profile, which it gets by default, but when we add a new profile, we have to explicitly list the default profile. And we're also now listing our new bridged profile. And we'll hit enter on that. It'll go ahead and launch the second container. And now we can do a Incus list. And we have the second container up and running, and it will get an address from our main LAN shortly. So my main LAN address range is 172.16.1 for my DHCP server, so it will get a 172.16.1 address. Let's do the Incus list again and see if it's gotten that address. And it has not yet. It might take just a little while, and we should see that address shortly. And there it is, 172.16.1.198. So we now have a container named second that is showing up on our main LAN. At this point, most of the Incus commands are pretty much identical to the LXD commands. So for example, I could say Incus stop first, and that'll go ahead and stop that first container. And if I do an Incus list, you'll see that that first container is stopped. And I can do an Incus delete first, and that first container will be deleted. And then if I do an Incus list, we only have the second container running. To actually interact with and connect to an Incus container, it's the same as a LXD container was, in that we can do an Incus shell, and we'll connect to our remaining container, which has the name second. Once we connect to it, we can of course perform commands like we would with any other operating system. We can do an apt update, and right now the container is completely updated. We can turn around and install other software on it. One thing that might be useful is if we were to do an apt install on open SSH-server, then we would have an open SSH server installed, so we'd be able to SSH to it. But before we can do that, we're going to need a user account. So of course we can do an add user on Scott, and then I can give Scott a password. And then I can do an IPA, and it looks like this container has an address of 172.16.1.198. So if I exit out of this, and I'm now back at the Incus level, I can say SSH over to 172.16.1.198, and I can say yes, and go ahead and type in the password for Scott, and it will log me in. And as you can see, I'm logged into this server named second with the username Scott. Right now, Incus and LXD are pretty much very similar from the command line perspective, but in the future I expect the Incus forks to diverge from LXD, and so there'll be different features in the future. So in summary, in the future, I will do a LXD to Incus migration video, and I haven't done that video yet because I've really been waiting for a GUI interface called Lex Console to mature just a little bit more before I do that migration video. So Incus is a reliable container management system. And if you follow all of the steps in this video, you'll have an operational Incus system that will be able to offer containers on your main LAN. So Incus containers are faster and more efficient than virtual machines, which must also emulate the hardware and which require an operating system installation. Anyway, that's it for today. Please subscribe and like the video, and don't forget to hit that notification bell, and we'll see you next time.